Hello, everyone. It's me, Dr. O. Today I'm going to introduce this problem. We did in the class, but I want to making a record for it to going over when you're trying to prepare the exam. So let's see. So first of all, this question is build up 95% confidence interval and about the population mean. So population mean confidence interval. So when you're looking at the population mean confidence interval, we come up with the two formula, which is x bar plus minus g alpha divided by 2 sigma over square root of n, and another one is x bar plus minus t alpha divided by 2 s over square root of n. So we need to decide which one is the correct formula for this question. In this case, the criteria of the determine this left one and the right one is from the fact that sigma is known or not. So in this case, there is no population parameter is known, and we try to build up the interval estimation. So we need to use this second formula. So we're gonna using this. Next, what are you gonna do? We need to find out each one of the values, right? X bar, S, N, and T values. So X bar is not known in these questions, right? And we know 16 observation and data point each one of them. So locally we can calculate it using the formula of the mean. X bar is equal to 1 over n summation of xi. In other words, we aggregate them together, total numbers divided by 16. So if you're doing that, right, each one of them, another way is x bar is equal to 1 over 16, 61 plus 85 plus and 83. So in other words, you adding all this value together and then divide by 16. So that's what you're going to do. And by doing so, you can get 80. So x bar is 80. And then what is next? So what is next is s square, right? S square is what? Sample standard sample variance. By square root of s squared, we can get the s. So again, the formula itself is s squared can be calculated 1 over n minus 1 summation of xi minus x bar squared. So in other words, in this case, 1 over 16 minus 1 is 15. And what you're going to do is each one of observation, 61 minus 80 x bar squared plus second one, 85. 85 minus 80 squared plus until 83. Each one of them, right? 92 minus 80 squared, 77 minus 80 squared, 83 minus 80 squared. Each one of them, and the very end, 83 minus 80 squared. And then we will get the value, and you will get we try to get finally s is the square root of s squared, which this value is, when you calculate it, you will get the 8.367. So I will not going through all the process, but yeah, you do a math and you will get that value. And we need a t-value too, looking at it, right? T-value is, in this case, t value is 95% confidence interval, so 95%. So we need a 0.025, which is 5% of alpha need to divide by 2 portion, building a confidence interval. Then left hand side 0.025, right hand side 0.025 is necessary. And also when you're looking at the t-table, you need to get a degree of freedom. Degree of freedom is defined n minus 1. So in this case, this 16 minus 1, which is 15. So this value you can get from this table, which is degree of freedom 15, right? Right here. And we need a t.025, right? Right here. And going down this column, and you can get the 2.131. So what I have is 2.131, 2.131. And all the value is ready right now. X bar, T alpha divided by 2, S, and N. So we plug in the value from here, which is 80 plus minus 2.131, S 8.367, N 16. And you need to calculate this right hand side of the value, but that value is, when you're using the calculator, you can get 4.457, which is 4.46. We round up the third digit. So our confidence interval is 80 minus 4.46 to 80 plus 4.46. So in other words, mu is greater than 75.54 and less than 84.46. So in other words, you can writing down using the open interval parenthesis 75.54 comma 84.46. That's it. So if you have a question, you can leave a question right here or send me an email. So hopefully it is helpful to you, and see you next time. Thank you very much.